I'm Hannah Patricia B. Samson.
I'm Cher Senga, aka Caps.
And I am Eunice Grace A. Rodelas, or you can also call me Uni, and we are from 10 Patients. We were tasked to create a podcast regarding our assigned topic, the derivation of formulas for combinations.
In this video, we will help you understand the derivation of the combination formula, which will help you see the formulas in probability and statistics can also be derived with some careful applications of definitions. After seeing formulas printed in a textbook or written on the board by a teacher, it is sometimes surprising to find out that many of these formulas can be derived from some fundamental definitions and careful thought. This is particularly true in probability when we examine the formula for combinations. The derivation of this formula really relies upon the multiplication principle.
Suppose that we have a task to do and this task is broken into two total steps. The first step can be done in k ways and the second step can be done in n ways. This means that when we multiply these numbers together, we will obtain the number of ways to perform the task as nk.
For example, if you have 10 kinds of ice cream to choose from and 3 different toppings, how many 1 scoop, 1 topping sundaes can you make? Multiply 3 by 10 to get 30 sundaes.
Now use this idea for the multiplication principle to derive the formula for the number of combination of R elements taken from a set of n elements. Let P and R denote the number of permutations of R elements from a set of n, and C and R denote the number of combinations of R elements from a set of n elements. Simply because a combination is the number of ways of selecting from a set when the order is not important.
Think about what happens when we form a permutation of R elements from a total of n. We can look at this as a two-step process.
First, we choose a set of R elements from a set of n. This is a combination and there are C, N, R ways to do this. The second step in the process is that once we have our R elements, we order them with R choices for the first, R minus 1 choice for the second, R minus 2 for the third, 2 choices for the penultimate, and 1 for the last. By the multiplication principle, there are R multiplied by R minus 1, multiplied by R minus 2, and so on and so forth, multiplied by 2 times 1 is equal to R exponential ways to do this.
To recap what we have discussed so far, P and R, the number of ways to form a permutation of R elements from a total n is determined by 1. Forming a combination of R elements out of a total of n in any one of C and R ways. 2. Ordering these R elements any one of R exponential ways. By the multiplication principle, the number of ways to form a permutation is P and R is equal to C and R times R exponential. Since we have formula for permutations, P and R is equal to n exponential over n minus R times R exponential, we may substitute this into this n exponential over n minus R exponential is equal to C and R exponential. Now solve this number of combinations C and R and see that C and R is equal to n exponential over R exponential times n minus R exponential. As we can see, a little bit of thought and algebra can go a long way. Other formulas in probability and statistics can also be derived with some careful applications of definitions.
In conclusion, combination, which refers to the number of ways of selecting from a set when the order is not important, unlike permutations, which needs a definite order. Combinations, keep in mind that no attention is paid to the order or arrangement of elements in the groups formed. Only a change in elements in the groups formed would be counted as a one-district combination. Thus, the combination formula is simply the permutation formula divided by the number of ways we can arrange R. Because in permutation, we are counting all the different arrangements in R ways, but in combinations, we are not counting all the different arrangements in R ways. This is why the combination formula is n exponential over r exponential times n minus r exponential.
Let us solve these two problems pertaining to combinations. Example 1. In how many ways can a committee consisting of 5 members be formed from 12 people?
Using the formula, then substituting the values, we can now answer the question.
792 ways. Example 2. How many ways can you form a 3-member group from a group of 25 students?
In this example, we will also be using the formula, then substitute the values, and we can answer the question.
2,300 ways.
We would like to acknowledge Courtney Taylor from thoughtco.com, 2015 Expert Guides Tutorial Services, Mathematics Reviewer, Khan Academy, Mathematics Learners Module Grade 10, and Mrs. Michelle Villanueva.